Hello guys, my name is Adrian and welcome to my channel. If you are new to the channel, I'm trying here to create a small game engine in order to be used for some future games. So far, we implemented a window. We have input for this window. We handle some number of events for this window, for example, like close. And today we will implement something very important, something that will help us to kind of use OpenGL, and we will implement for sure something called window context. Because we are using OpenGL, we need to create this window context. If we will use at some point Vulkan or DirectX, we don't need this context to be created. But because it's much easier to start with OpenGL, we will implement such a thing. So, for those also that are new to the channel, we implement our game engine in a couple of modules. We have the commons, graphics, platforms. Graphics and commons, we didn't work on them yet, but we were focused mainly on platform. So, in the platform, in the base folder, we implement a new header called window context. Like for any other base class that we have in our window context, we'll declare the namespace core base, and we will create a class window context. After that, in our Windows implementation, we will define a new class. Of course, it will be called window context. In this window context, from the Windows folder, this is the place where the magic happens on the Windows platform. So, first, we need to kind of, let's say, make use of the window context CPP for sure. If we want, we can kind of, let's say, put this like this, just a small alignment, but this is not necessary for a game engine most of the time. Okay, so in here we will change the namespace to Windows. We need to do this the same here. And what we need to do, of course, we need to include core base window context. We will inherit the base class, so we'll have a final public core base window context. And now the magic happens. In the base class, we need to implement a bunch of, let's say, virtual functions. A good example on how we will do it, it can be the Windows events or the window. In the window events and window input, we kind of create the init release methods, but for the window, we use create and destroy. We'll use the same create and destroy mechanism for our context. So we'll have a virtual auto, something called create, and in it we will have a constant std unique pointer. We'll have a window, and of course we need to include a window. Why we are including the window .hpp? Because we need the handle of it. Okay, when you are creating a window context, you need to specify the handle. The same applies to Vulkan. In Vulkan, when you want to create your, let's say, surface to draw the graphics, you need to specify for which window that surface is created. Okay, so let's continue. We have a constant reference on a unique pointer. We are using this. It means that we don't pass the, let's say, the reference. We don't want to keep that. We will need at some point a destructor, of course. After that, virtual, depends on your country, let's say, destroy. we need this destroy also to be, how to say, pure virtual. And after that, we'll have a virtual auto update, the same. Other than that, we don't need any more things. So we have this, we need to inherit this create, destroy, update functions. And we need to kind of, let's say, add the code that is necessary. But before that, let's have this. Just a second. So we have the methods. Let's generate them as empty for now. But what we need to do in the platforms factory, we need for sure to include a window context. Let's see. Let's sort it. So it will be the first one. So virtual auto create create window context. Okay, we will align these things later. In the platforms here, we need to add these functions also. This function, sorry. And in here, of course, include window context. So this is very similar with what we did with the, let's say, last, let's say, window structures, like for input, events, and so on. So now we are having the context. That's okay. In the window manager, what I will want to do, I will want to have a window context also here. Also a reference to the window context here. That's very simple. And just a second here, return. Let's have a reference to the window context. So we have the context, that's okay. What we can do after we are having the window, we can create a window context. And what we can do with this window context, we can call create. And for the create, we will need to send the window. That's pretty much it. What we will need to do also, it will be, we need to destroy the window context. That's one thing. And nothing more than this. So what it will mean now, when we are running the project, we have a window context. Now, if we are going into our main file, and in here, we do something like window manager, window context, and I will call update. In this update, we should do something called swap buffers. Different than the Vulkan, in Vulkan, you need to handle that swap buffer stuff. You still have some functions there, but it's let's say correctly, it's more work to do it. In the OpenGL, it's easier because somehow the API, let's say the platform specific API will handle things behind the scenes. In Vulkan, it's a little different. At some point, I hope we will show how it is. So let's go into our window. Let's have a private, and we will declare here like a hash G LRC, and we will have hash RC, and another one is hash DC, and the same. So let's see what this means. This is the handle to a device context. This is like handle device context hash DC. And this, for example, if I remember correctly, it's a handle to a GL, okay, rendering context. I hope I'm not mistaken, but I think this is, if I remember correctly, these are the, let's say, the names. So we are having this. What remains for us? First, into the create. In the create, we do a constant expression, for example, and we will have a pixel format descriptor called PFD. Okay. And in it, we need to do something about the n size, which should be the size of the pixel descriptor structure. And after that, we have some DW flags, which should be PFD from pixel description or of pixel format description, sorry. So we will have something like draw to window, PFD support OpenGL, and something like PFD double buffer. Nothing more than that. After that, what we need to do, #dc. So the device context, we need to use something like get dc. This is a function from Windows API. And for it, we need to have something like an std, any cast. We need to handle to the, let's say, the Windows specific window, or let's say to the window handle specific on Windows mainly. So we'll have #nd, and the end we'll put the window handle. Something similar we did for the, let's say, for the events, like in here. Okay, we are doing the same stuff. We are trying to take the handle and to cast it to the platform specific situation. Here we'll have an if, and we try to call this set pixel format, which takes an #dc, and it also need the second parameter to return something from choose pixel format with also again #dc, reference to the PFD. Okay, so that choose pixel format will return something for us, like an index, let's say, or a format description. And the set pixel format, it will kind of, so this will return, if we are going here, it will return mostly like an index, okay? And it will say like, hey, based on what you put here as a pixel descriptor, or pixel format descriptor, you said that you want something that can be drawn in a window that supports OpenGL and has double buffer. And you are trying to set it, okay, to set this pixel format descriptor. And what this choose pixel format gives you just an index, okay? So we are trying to do that. If we are not successful, we are having an exit with exit failure. That's okay. If everything is okay, we are doing like, we take the rendering context and we create context, and based on the device context that we just, let's say, get, and kind of put the pixel format for it. At the end, WGL make current function. This is a function, whatever you see here with WGL, this is from Windows Code or Windows API. In GLFW, if you remember correctly, in that library, you always at some point in time you need to call the function glwf make current. In the behind the scenes, this is what happens. Okay, you are calling this. I prefer to call it in this create function and not have it separately. So that's okay. In the destroy, we are doing WGL make current, and for both of the parameters we are using null pointer. That's okay, because we don't want to bind at any, like we just want to destroy it. And at the end, we are calling delete context on our rendering context situation. And of course, into the update, we just call this internal function swap buffers that is part of the Windows API. If I'm trying to run now the project, everything should work. If you remember correctly, at the beginning of this tutorial, or not tutorial, this step of our journey, let's call it this way, our window was like white. Okay, now it's black. It means that it has some context for the OpenGL. We don't have any functions yet to be called here, but it means that things are having, and we are ready to have OpenGL context. If we are kind of commenting these situations, let's see here. If we comment here, we'll see that everything is back to white. Okay, no context, nothing happens. But we want to keep this context here, okay, because we implemented and we will need it. But what we implemented today, we have our OpenGL context for the window, but this is just the first step. And what we did today is just a part. What it means with that? It means that we can access OpenGL, but not the modern OpenGL. For modern OpenGL, we will need to enrich our window context, and we will need to kind of extend it, and we will get into some point where we will need also to take some pointers to some functions that will help us to create this modern OpenGL context. What we implemented today is still useful, and we will still need it, but in order to do stuff that it's modern nowadays and more, let's say, closer to the Vulkan in terms of OpenGL, we will need to work more. So this is what we have so far for today. We have a primitive OpenGL context. In the next video, we will kind of enrich this message. If you're new to the channel, don't forget to subscribe. I'm trying to put this journey for us, for me. I want to put this engine in some, let's say, or to achieve some milestone for it in order to, I don't know, write in stone that, hey, this is enough to make a game. And yeah, this is it for today. Also, I already had like a mic that was kind of okay in price, but I bought another one which is 3 times expensive than the one that I have right now. And I hope soon in the next videos when I will use it. Right now I'm still on the old mic. I hope the sound will kind of sound better. Thanks for watching. Have a nice day. Have a nice weekend, or whatever it's still in from this weekend, and see you in the next video where we will talk about the Windows context with the modern OpenGL flavor to it. Have a nice day. Bye bye.